Worksheet 9D and the last worksheet for today's lesson. Draw, shear, and bending moment diagrams for the beam loaded as shown. Even the problem doesn't ask us to find out the external reaction, but you still have to find out your good statics to take moment, etc. So in this case, with that external load, if you take moment about F, you can find out the reaction, vertical reaction at the roller C equal to 21 gips. Similarly, if you sum up all the force in y direction, after find that out at the C, then the reaction at F equal to 11 gips. And to make sure you do correctly, you can even take moment about C to see if the reaction at F equal to 11 gips. And of course, the horizontal reaction at F equal to 0. There is no horizontal load applied on these beams. So from that, we can go ahead to find out the shear and moment diagram. So this, as you can see, include everything: distributed load, uniformly triangular distributed load, couple moment, concentrated load. So with that, as you can see, this represents all of things that we learned so far. So if you be able to, without seeing the video, you be able to solve this problem, then you really understand shear and moment diagram. So try challenge yourself before you watch this video. So let's start with the shear diagram. We always start from left again and start with 0. 10 keeps going down, so it will create a discontinuity, move down because it's going down there. So it will be 10, negative 10 here, from 0 going down because that concentrated load 10 keeps. From A to B, there are nothing, so you will have a constant shear for 2 feet. At B, the couple 10 foot keeps apply, and for the couple, it only causes a discontinuity in the moment diagram, not shear. So shear keep going until the roller support at C. And at the roller support, we have the 21 kips going up, so it causes the discontinuity on the shear diagram and move up. So it here 10, so it move up to 11 to get 21. So it here plus 11 kips, move up here for 21 kips. And find out the area under the load curve of the triangular shape. 4 kips per foot times 3. So 4 times 3, 12 divided by 2 for triangle. So it will be equal to 6 negative in this area. So 6 negative. So from 11, the change in shear equal to the area under the load curve. Load curve change negative, the area under the load curve is negative 6. So it's going down from 11 to 5 plus 5 to make the change is negative 6. And because the triangular distribution, then load distribution, then the shear it have to be parabola. And in this case, as you can see, for the distributed load, 0 there, and 4 kips per foot in that point. So by now, I don't need to draw 2, but you can see it will be 0 parabolic going down in that, and that it will be S in here, and this is a parabolic, as you can see there. And 0 slope when they start at C, and then reduce gradually until you get the shear at 5 kips. And then D and E, the area under the load curve, nothing. So you see the shear, it remain unchanged because there no load in there. Remain unchanged, still plus 5 kips. And then next, the area under the load curve for the uniform distributed load 4 times 4 equal to 16, and going down, so it will be negative 16 for the area under the load curve. So as you can see, 5 plus 5 in here, 16 going down, so it will get back to the negative 11 kips to get the change 16. So from here, up here, there, and 11, we have a concentrated load. Actually, that the external load external reaction at pinch app going up 11 kips. It will cause the discontinuity on the shear diagram and move up, so it will be 11, and it ended 0. So that we do correctly. Everyone see that? So that shear diagram, and we have that as straight line, and this also straight line. Okay, so that is shear diagram. And now the moment diagram. Before we look at the moment to find out the areas. So let's divide some chain in here, some there, to get the area for each portion. So the first one, simple, negative 10 times 2. So you have that one is negative 20. Similar, this rectangle, negative 20. And why we divide by 2? Because you see there is a couple at B. So that's why we have to separate, not negative 40. For the next portion, you have that first, the rectangle 5 times 3. 5 times 3 rectangle, so it will be 15. And positive for that portion. And now the next one is parabola. What is the area for that parabola? As you do in the previous problem, it will be 1/3 6 times negative 15 with the 2, so 1/3 AH for that. Then, as you can see, the next one, if we have close the whole area here, so if the whole rectangle, so you have that is whole blue rectangle that I put it in there, it will be 6 times 15. The top portion above the parabola is 1/3, as you can see. So the portion here have to be 2/3. So let me erase that and go back to the original problem we have in the next problem that we want to find out. So this is 10 kilonewton. Going down here, we have two areas, and the first areas is portion, and this portion is, let me draw the parabola on the right side here. If I have a rectangle and a parabolic, this is H, this is A, and use, and in this case I put that in P. Use the reference that you have earlier for the parabolic square, that portion equal to AH over 3, then the complement of that one, the complement areas of that one, the red complement that I show you there, it will be equal to 2AH over 3. Because the whole thing is the rectangle. Let me put down here the purple. The whole thing of this purple here. The purple one. The purple. Have to be the areas of the purple. Have to be equal to, for the rectangle, right? So it will be AH. So, the set it AH over 3. The red, 2H over 3. Add them up. Have to be equal to the purple, AH. 2/3 AH plus 1/3 AH. It will be AH. Everyone okay? So with that, we can go back to here. With that geometry, you can see that this, the question mark is not 1/3 AH, but it actually 2/3 with that portion. So right down here, you can see the areas of that one. Area 1 equal to 1/3 AH, and the area 2 equal to 2 AH, 2/3 AH. Keep that in mind. So the question mark that we have here is 2/3 of AH. So from there, we can have that equal to, this question mark become 2 times A, in this case 3 feet, times H plus 11 minus 5, so it equal to 6. So 3 times 6 and times 2 divided by 3 is 2/3, so it will be 12. That area is plus 12. Everyone see that? 2/3 AH 12. So the total it will be 27 for the whole areas of under the shear curve at that areas. And then go back to here, that already have, and then we have it here, that easy 5 times 3, so you have it 15 positive. Now another tricky part, where is that location to find out the triangle here, because we need to find the triangle, the positive and the negative. So to have that, they separate way, but that I make a easy way for you here. The slope of the shear curve equal to the magnitude of the load. So the magnitude of the load is 4 kips per feet. So that slope here, as you can see, that slope equal to -4 kips per feet, because that is the yield. The slope of the shear diagram equal to magnitude of the distributed load, in this case uniform and going down, so